Hello and welcome to the Fortress West Point mini sprint review video. Put succinctly, our product vision is to create an immersive, geographically based augmented reality application that enhances the historical experience that West Point naturally provides via a virtual staff ride. Our product vision is guided by the desires and specifications of Colonel Sedgley of the History Department, who is our product owner. Our goal for this sprint primarily revolved around figuring out how to work together using the Agile framework and establishing standard practices for future sprints. We also spent a considerable amount of time on knowledge acquisition, which will carry over greatly into Sprint 1. Our expected capacity for this sprint was 66 hours, when in reality we fell just short of that and came in at 65 hours. Certain product backlog items took far less, and certain product backlog items took far more time than we had anticipated. A point of improvement is just ensuring that we're realistic with ourselves and with each other on how long certain tasks will take and spending more time in that estimation. Some of our deviation from our plan is due to simple things such as lack of experience or improper estimations, but other things were due to poor planning on our part, such as our failure to meet with our history majors and back brief them on kind of everything we've done so far in the mini sprint project.
So one of the first things that we had to do was figure out how we were going to integrate GPS into our augmented reality app. To do this, we had to do a little bit of research, which Ryan took care of, and he found the Code School app, which would allow for us to use Google Maps in our SDK. So basically what everyone had to do was take part in completing a little bit of this Code School. So we all went to the website and played through all of the levels in order to get the badge, which it doesn't say a whole lot for our accomplishment here, but now everyone has somewhat of a background in it, and therefore once we are ready to move into it, we have some of our resources available.
So after the GPS SDK Code School, we began to start working on the iOS Swift and kind of getting familiar with Xcode and developing an app. For this, we found a few different resources. We found a Code School app. Unfortunately for this tutorial, only level 1 was available for free. The rest of the course required membership. So we required that everyone complete level 1 for this tutorial, which essentially just gets you familiar with the basic Xcode layout. As you can see, pretty simple stuff. And then after that, we required that you go to the Apple developer walkthrough, and this just talks about how to walk through building your first app, essentially. And so the first app that it helps you work on is this meal planner. And the first thing it does is walk you through building the UI. As you can see, it goes through the steps of adding different text boxes, kind of just setting up the actual app itself at the beginning. You can add buttons in later, and just the basic layout of Xcode is displayed here. Once the UI was made, it then starts talking about how to implement code and then connect that to the UI itself. We will now show you an example of what we did. So this is just kind of an example. So on the left you see the UI, which has got a text box. And then underneath that, there you can enter text, which would be the meal that you're going to eat. And then this is the button that's actually interactable if you launch the app. And then over here we've got the actual code, which this stuff actually connects to the app itself in the UI. For example, that title connects to that piece of code and that text box connects to that piece of code. So once everyone completed that, we then practiced some daily Scrum. This includes actually doing the daily Scrum, but the day before we presented in front of we practiced actually doing this Scrum for about 30 minutes. And now we are currently working on recording and editing.
Hello, my name is Craig Shoes. For this sprint, the deliverable that I provided was the decision matrix for which software development kit we wanted to use to develop our app. For this decision matrix, we went with a lower is better scoring system, as well as using different weights to represent which criteria mattered more to us. The first criteria we had was cost, which we gave a weight of 1. Apple ARKit scored the highest for this criteria. Using the developer program account, which is $99 a year, we would be able to distribute our app on the App Store. The Wikitude AR SDK cost $3,000 a year, which we found to be very expensive and thus gave it a worse score. The Vuforia SDK costs $500 for basic access and an additional $100 a month in order to use cloud capabilities. The second criteria we evaluated was speed, which we also gave a weight of 1. We found that Apple ARKit would be the fastest of the 3 software development kits because it's designed by Apple specifically to use their processors extremely efficiently. The Wikitude SDK scored a 2. It's non-native software, which would undoubtedly include some overhead which would limit speed. Similarly, the Vuforia SDK also scored a 2. Like Wikitude, it's not a native software development app like ARKit and thus would include some overhead. For multi-platform capabilities, Apple ARKit scored a 2. This is because it's only available on iOS 11 and thus cannot be implemented on any other platform. We gave the multi-platform capabilities criteria a weight of 1 because Colonel Essentially had mentioned that he would like us to implement on Apple devices first and later add capabilities for the other platforms. Wikitude AR SDK scored a 1 in this category since it's available for most major platforms, as did Vuforia. For ease of device implementation, we weighted this a 2 because the implementation itself is something we can see taking a good portion of our time. Apple ARKit scored a 1 in this because it's native to the iPhone and iPad, so implementation will be made easy through the App Developer Kit. Vuforia scored a 2. It boasts on its website that iOS developers can quickly add the Vuforia engine to existing iOS projects. Wikitude AR SDK scored a 3. It's not native, and it may be harder to implement. Our fifth criteria, familiarity with development environment, we gave a weight of 1. As we explored the various SDKs, we realized we weren't very familiar with any of them. Thus, all 3 scored a 2. Our last criteria, offline use capabilities, we gave a weight of 2 because it's something that Colonel Sedgley specifically mentioned he wanted us to integrate into our app. Apple ARKit was given a score of 2. The App Store developer lets you integrate offline libraries, but we are unsure of how we would integrate these and implement them and what data structure we would have to create to do so. This is the same for the Wikitude AR SDK. Not only are offline use capabilities only available for the cloud version, but we're unsure of which data structures we would have to implement in order to create a database which would allow for the storage of targets and other AR-related material. For the Vuforia SDK, this was rated the highest because it comes with a native database system which allows you to store the targets and the other AR-related material on the app, and it can be updated or included at installation. In conclusion, the Apple ARKit edged out Vuforia 12 to 13, with Wikitude coming in at 18. Therefore, we decided to use Apple ARKit for our software development kit.
The work we did in the Sprint Mini project was able to help us narrow down our focus and establish a sprint goal for Sprint 1, which will be designing a prototype UI for the app. For our future sprints, we will be less focused on research and lit reviews, and our work will primarily be geared towards the actual development and testing of the app. In conclusion, we met our goal for the Sprint Mini project and feel confident working as a team moving into Sprint 1. However, close coordination and integration between developers will be crucial, along with testing and constant evaluation as we move forward into more intricate and complicated portions of our project development.